বলে একটু জাস্ট ওইখান থেকে আওয়াজ দিন, হয়ে গেছে এরকম আওয়াজ দিন, আমি শুনতে পারি। আমার অ্যাকচুয়ালি N95 মাস্ক লাগবে।
আছে 300 টাকা আমাদের খালি দুটোই নিয়ম আছে সব বলি রাত্রেবেলা মাস্ক হয়ে গেছে।
আপনি ওই কম দামের হলে আপনি একটা কাজ করেন, আপনি 200 টাকা রাখেন। যদি কম দামের হয় তাহলে 400 নিয়ে নিন, আর যদি বেশি দামের হয় তাহলে 300 নিয়ে নিন, আর সেই ক্ষেত্রে যে ওভার পয়সাটা হবে ওটা অ্যাকাউন্ট থেকে নিয়ে নিন। আর পলিউশনটা আপনি অ্যাকাউন্টের টাকা থেকেই করেন। আর পলিউশনটা হয়ে যাবে, ওটাই আমি বুঝেছি, বলতে গেছি ওটা হয়ে যাবে। ওটা আপনি যেভাবে করিয়ে নিন, কারণ নাহলে পরবর্তী প্রাইভেট যেভাবে যেভাবে বুঝতে পারছি। আর কালকে তো সব মেন কালকে সব বড়ো বড়ো দিদি সব সংস্কৃতিগুলো করবেন, মানে আপনারও থাকবে বড়ো বড়ো দিদি সব সংস্কৃতিগুলো। আপনি এটা কাজ করবেন না, আপনি গাড়িতে সবাইকে পিছনে গিয়ে অ্যাকাউন্ট অ্যাপোলো থেকে ছোটোটা হলে 200 টাকা পুরো করে দিন চার্জে। আর যদি বড়োটা হয়, যদি ছোটোটা একদমই না থাকে, বড়োটা থাকে, বড়োটা 300 নিন, আর ওভার পয়সাটা অ্যাকাউন্টে। Okay, good afternoon all of you. In the second session of physics refraction, we are now going to discuss about the laws of refraction. So the laws of refraction are called SNELLS laws. So suppose there is a triangle ABC which is right angled at A. Okay, suppose there is a triangle ABC which is right angled at A. So this angle A, it's a acute angle obviously. So this angle has got a property that is called sine. Okay, it's actually the full form is SINE, but short we write SIN. So sine A, what is that property? What is sine A? It literally means opposite by hypotenuse. Like sine A, the side opposite to A, that is BC, by hypotenuse is AC. So sine A is opposite by hypotenuse, so BC by AC. So this is called sine A. Now, what happened was that the people who brought trigonometry into our lives, they were the Greeks. Now they made a very interesting discovery. They discovered that if you are finding sine A is BC by AC, they discovered something, that it does not depend on the measurement of AC, BC and AC. It is a property of this angle. So this was a discovery made by the Greeks. They discovered that if you say sine A, then A is an acute angle. It will have some value because this is a right angle triangle. So A has to be an acute angle. So it will have some value, 40 degree, 50 degree, whatever. So they made a discovery, the Greeks, that the sine of A is BC by AC. So it seems that it depends on the measurements of this triangle, but they discovered that it does not. It actually depends only on the angle. So if I have a particular angle, it will have a particular sine. They discovered that. So keeping that in mind, they gave a table called standard angles. So they gave a table called standard angles. So this is the table which was given by the Greeks. This is called table of standard angle. So sine of 0 degree is 0, sine of 30 degree is half, sine of 45 degree is 1 by root 2, sine of 60 degree is root 3 by 2, and sine of 90 degree is 1. So this was stated by the Greeks. So they gave this standard angle table and they said that if you want to find sine of these angles, you can just pick it up from this table. You do not have to draw a triangle, okay, with one of these angles, and 90 degree has to be there, and then do the measurement and then divide it and see. No, don't have to do that. If you have any one of these angles, you just pick up the sine from this chart. So this was stated by the Greeks. Okay, now this is all part of trigonometry, and we are not really keen on going into trigonometry in full form now, because trigonometry is a branch of mathematics. But we are going to do something called Snell's laws, and without the knowledge of sine, SIN sine, you cannot do Snell's laws. So what are Snell's laws? So this scientist Snell, he gave two laws. The law number 1, incident ray So the first law was that incident ray, refracted ray and normal lie on the same plane. So this was the first law given by Snell, that whenever there is refraction, the incident ray, refracted ray and normal, they will all lie on the same plane. What is the meaning of this law? What does this law mean? Actually, this is the normal, this is the incident ray, and this is the refracted ray. Now, when you say plane, anything which is totally flat is called a plane. For example, this entire whiteboard, the surface of this whiteboard, it's plane. Okay, the table, the table on which you are sitting and doing your work now, the top of that table is a plane. So any flat surface is a plane. The simplest plane figure is a triangle, and then you have quadrilateral, then you have pentagon, and so on. And the most extreme form of plane figure is of course circle. Okay. So the incident ray, this is the incident ray, the refracted ray, this is a refracted ray, and the normal, they will all lie on the same plane. This is the first law. So you can see that I have drawn the incident ray, refracted ray, and normal on the plane of this whiteboard. So the incident ray, refracted ray, and normal, they are all on the same plane, and that plane is the plane of this whiteboard. This is law number 1. Now, in the previous session, we have had a discussion on refractive index, and I have told you that refractive index of a particular medium with respect to another medium, how to find it. So I told you that it is speed of light in the first medium by speed of light in the second medium. That's what I told you. Now Snell made a discovery that if you do sine of the angle of incidence, this is the angle of incidence, this is the angle of refraction. So Snell made a discovery, if you do sine of the angle of incidence by sine of the angle of refraction, like if you do sin I by sin R, then that will also come out to be the refractive index of medium 2 with respect to medium 1. So this was a discovery made by Snell. So sin I divided by sin R will be refractive index of medium 2 with respect to medium 1. So this was the second law of Snell. So collectively these two are called Snell's laws. So it's interesting that we have already discussed refractive index in our previous session, and we know that refractive index is the ratio of the speed of light in the first medium by speed of light in the second medium. We have already discussed that. We already know how to find refractive index. We know it. But Snell gave another formula, that is sin I by sin R. And this formula, is it better than the previous formula? Well, it is a little better because there are ways of finding out sin I and sin R. In laboratory we can do a setup to find sin I, sin R, but measuring speed of light in a medium is not a very simple setup. So if you want to find refractive index by doing speed of light divided by speed of light, a slightly elaborate setup is required. Whereas sin I by sin R, there is a very basic setup in the laboratory, you can do that to find sin I by sin R. So overall, yes, this is a better formula in terms of usage. So these two together are called Snell's laws, right? Now I just want to clarify that when you say refractive index of 2 with respect to 1, so I am keeping it very general. So you all know very well that if the first medium is vacuum, then automatically this refractive index is the absolute refractive index of the second medium. That you all know. That's what I told you the last time. That suppose if medium number 1 is vacuum and medium number 2 is some other medium, then automatically it will be the absolute refractive index. One more thing which you must have definitely noted from our previous discussion, that absolute refractive index of any medium, it will either be 1, otherwise it will be greater than 1. This you must have noted. So absolute refractive index is always equal to or greater than 1 simply because the speed of light cannot be more than that of vacuum. So vacuum's speed of light is the highest and any other medium will be lesser than that. So that is why you don't have to, those quality properties will not change. Those properties will remain the same even if you use this formula, right? So once again I'm saying, in case the first medium is vacuum, then this refractive index is the absolute refractive index, number 1. Number 2, you know that speed of light in vacuum by speed of light in the medium, but you know that speed of light in a medium has to be less than 3 × 10⁸, and speed of light in vacuum is the highest. So refractive index will always be more than 1, but if you are wanting refractive index of vacuum, it will be exactly equal to 1, right? So these all things which we discussed in the last session, they are all applicable now also. The only thing is we have introduced a new method to calculate the refractive index, that is sin I by sin R. But whatever we have discussed in the previous session, all that is still applicable. Everything of the previous session is carried forward to this session with this extra sin I by sin R formula. And of course, this is a law which is qualitative. We will not, the first law, we will not use it in a numerical. It's a qualitative law. You just need to understand that incident ray, refracted ray and normal lie on the same plane, right? So in this session the topic is Snell's law, and now based on this I am giving you some homework. Okay, now the first homework question is that a ray of light is coming from air inside a liquid. So over here the angle is 30 degree, over here the angle is 45 degree, right? Here it's 30 degree, here it's 45 degree. This is the incident ray, this is the refracted ray. So question is, what is the angle of incidence, what is angle of refraction, and what is refractive index of the liquid with respect to air. So this is the normal. The angle between the incident ray and the surface is 30 degree, refracted ray and surface is 45 degree. So what is the angle of incidence, what is the angle of refraction, and what is refractive index of liquid with respect to air? This is question number 1. Okay, question number 2, the angle of incidence is 45 degree, angle of refraction is 30 degree, this is air, this is liquid. Find the refractive index of the liquid. This is question number 2. Then question number 3. The angle of incidence in air is 30 degree and the angle of refraction in glass is 19.5 degree, and you are given that sine 19.5 degree is 1/3. So the question is find the refractive index of glass. Okay, question number 4. Question number 4. Can Snell's second law be used for normal incidence? That means the sin I by sin R formula, can you use it for normal incidence? Normal incidence means that this incident ray is striking the boundary along the normal, like the incident ray and normal both are same. Normal incidence means that the incident ray and normal both are same. So can Snell's law be used for normal incidence? Normal incidence means that the incident ray is striking the boundary of the two mediums along the normal. So can you use Snell's law in this situation? That is the question number 4. Okay, question number 5. Question number 5. There is a ray of light which is originating from water. Okay, there is a ray of light which is originating from water. It is striking the boundary of air and water, and angle of incidence on the water side is 45 degree. Like on the side of water, the angle of incidence is 45 degree. So it is striking the boundary between air and water, and then it is moving along the water surface. Like it is striking the water surface and then it is moving along the water surface like this, and this is air. So it is having angle of incidence 45, and after being incident on the boundary between air and water, that means after being incident on the water surface, it is moving along the water surface like this. So in this situation, you will have to say what is the refractive index of water. So this is question number 5. So these are the 5 homework questions for the next session. You will have to submit the homework questions before 9 p.m. tomorrow, that is 9 p.m. Thursday. Today you don't have to submit it. Okay. So I'll conclude the session. Thanks a lot all of you. I'll end the session now. Bye.